Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back to my channel. And today we're going to do a review of the properties of real numbers. Let's go ahead and jump on in. So, number one, which statement cannot be justified by one of the properties of real numbers? Now, the main thing they italicize cannot, and the other thing we need to make sure we pay attention to is the properties of real numbers. So let's review that. As you see, I put a list or a little chart up here displaying some of the properties of real numbers. The first property at the top, the distributive property, refers to multiplication. That's the main thing you want to remember when you're using or looking for the distributive property. You're going to have one term outside of a group being multiplied times however many items are in the group. So for example, you have 3 times the group of 4 plus 5. That's going to be 3 times 4 plus 3 times 5. Now, the commutative property, which applies to addition and multiplication, the main focus there is that the terms or the items, the numbers, will switch places. So for addition, 3 plus 4 is the same as 4 plus 3. And versus multiplication, which is the same as saying 3 times 4 is the same as 4 times 3. So commutative property, the items or the numbers or the terms just switch places. Now, the associative property, which there's an associative property of addition and an associative property of multiplication, both imply or refer to the regrouping of numbers. So most times, the numbers, when you see the associative property displayed, the numbers will stay in the same order, but you'll see the parentheses move or the groups move or change. And that's what you see in those last 2 examples in 4 and 5, okay? Now, just to finish out, we will review 2 more properties, the identity property and the inverse property. Now, the identity property for both addition and multiplication basically have it so that the value is unchanged. So with addition, anytime you add anything to 0, you get that same thing. So 4 plus 0 is 4. 10 plus 0 is 10. 0 plus 11 is 11. Now with multiplication, when you multiply 1 times anything, you get that same thing. So for example, you have 4 times 1, that equals 4. 5 times 1 equals 5. 10 times 1 equals 10. So 1 times anything is going to give you that same thing with multiplication. And with addition, it's 0 plus anything gives you the same thing. Now, the inverse property simply states for addition, the additive inverse property is basically adding opposites equals 0. And for multiplication, once again, the magic number is 1. So multiplying reciprocals equals 1. Okay, that's the multiplicative inverse property. All right, now that we've discussed that and gone over those things, what did all these properties have in common? Well, they share addition and multiplication. All of those properties of real numbers apply to addition and multiplication. And with that knowledge alone, if you already know your properties and you know that they apply to addition and multiplication and you're trying to figure out which one cannot be justified, you would simply choose answer choice B. Okay, because A is the associative property of addition, C is the associative property of multiplication, and D is the commutative property of addition. Now, some of you all may be asking yourself, well, what if I don't remember my properties? What if I'm not good with that? There's another thing you could focus on, which is in the first half of the statement. It says, which statement cannot be justified? If we focus on just that phrase, cannot be justified, in math, that means that it's not true. Or in other words, that it is not equal. The 2 sides are not equal to one another. So with that knowledge, what you could do if you don't remember your properties is assign a value to A, B, and C. So for example, I assigned A equals 5, B equals 1, and C equals 2. And then I worked out all of the problems, all of the answer choices. And as you can see, the answer is still B because B is the only one where both sides were not equal. When you did A, C, and D, if you work those out, both sides equaled the same thing. And that's how you would answer this question.